Welcome back, engineers. IndyDevDan here. I'm going to spoil this one and just tell you this video is an absolute banger. Thanks to Anthropic, we have the brand new Claude 4 model series. We have a new Sonnet and a new Opus model, and very importantly, a lot of engineers are going to miss this, but we have Claude Code now generally available. This means we can bet big on the best agentic coding tool with now the new state-of-the-art models for effective agentic engineering at scale. We have the Opus 4 and the Sonnet 4 models beating out every model for real engineering work. This is big. Today, I want to share a dirty parallel AI coding trick you can use to put multiple agentic coding agents to work for you to generate multiple versions of the future of your code base. I have to warn you, this is advanced agentic coding and it's not cheap. We're going to put together a plan, then we're going to deploy that plan against multiple agents working on their own versions of your code base. Then we're going to take the best version and merge it back into the main timeline, the main branch. Thanks to the Claude 4 series, this technique has never been more important and it's never been more possible. Let me show you exactly what I mean. Let's parallelize our agentic coding with the new Claude 4 series. So we've gone from iteratively planning to writing larger prompts to writing plans, and now we're going to take it a step further. We're going to put multiple agents to work for us at the same time in parallel. This advanced agentic coding technique has massive benefits. Let's understand what we're working on. We're going to operate on a simple code base called Benchy. This is the Thought Bench application. This is a simple front-end plus back-end application that lets us talk to multiple models at the same time. You can see we have the brand new Claude and Opus 4 models running. So it's really important to showcase multi-agent agentic coding against a UI application. So we're going to improve this UI, update the styling here a little bit, but we're going to run multiple versions of Claude Code to accomplish this task for us. Let's set that up. Claude Code is updated. It's generally available. This is big news. That means we can bet big on Claude Code. We can type /model. We can select our model. I'm going to go ahead and use the brand new top of the line Opus 4 model here. In order for us to get this work done, we create plans. Iterative AI coding is the 2024 way of doing things. If you want to ship a ton of value, you want to sit down, plan out your work, and then fire it off to a powerful agentic coding tool. So we have this UI revamp prompt inside of the code base. Basically, it's detailing all the work we want done. The top line here is that we want to transform Thought Bench into a high density information dashboard while maintaining a great user experience. So this is the prompt we want to run. Normally, I would copy the reference to this with Command-Shift-R. That's my hotkey for this. And then I'd say implement this. And then Claude Code would run this, execute it, update our current branch. But we can do a lot better by running multiple agents in their own environments. So what does that look like? If we open up .claude.commands inside of the Benchy code base, you'll see this simple init parallel prompt. What is this prompt doing? This prompt is going to set up our new Git Worktrees. As you saw here in this diagram, we can use this Git command, Git Worktree add, to specify a location, right? So you can see in our trees directory here, we're going to create a UI revamp 1 directory, and it's going to basically duplicate our entire Benchy code base. We can, of course, scale this up, right? We want multiple agents building out the exact same feature. LLMs are non-deterministic by nature. So by parallelizing them, we can get different versions of the future of our code base, and then we can select the best one. So let's kick this off, and then we'll break down the prompt as it's executing. So we're going to type /simple init parallel. You can see here inside of the prompt, we're setting up a variable. This is a technique I like to use to reference variables throughout the prompt. Claude Code /commands lets us set up and pass in variables. So I'm going to name this feature. We're going to call it UI rewrite. And that's it. So we're passing in one parameter. This is going to replace this here. And let's kick this prompt off. So Claude Code running on Claude 4 Opus is going to create our trees directory. You can see that command right there. And then it's going to execute these steps in parallel. It's going to create a new Git Worktree. is going to copy the .env environment variable into the right folder, and it's going to cd into the server, install dependencies, do the same thing on the front end using bun, update our Vite config to run on a different port. Remember, we want to run these in parallel. We want to compare all the results. And you can see here our agentic workflow is running in parallel. It's kicking off all these tasks in their own dedicated environments. If we open up UI Rewrite 1, you can see here we have a direct clone of the entire code base. There's .claude, there's the client, there's the server, right? So it's the exact same thing as the root of the application. We've quite literally, thanks to Git Worktrees, cloned our entire code base into 3 separate versions. I hope you can see where this is going, right? There we go. We have our Vite config update. Let's go ahead and turn on auto edit mode. And now we're going to get parallel writes. And as Opus runs into errors, right, it's just going to work through them. It's going to fix them. It's updating every version of our application. We have entire environment set up. There's the Git Worktree list. We now have 3 brand new work trees, and Claude 4 Opus has completed this agentic workflow. And to be completely clear, that's what this is, all right? This is not a prompt, right? We're not running traditional prompts anymore. We're running agentic workflows. Principal AI coding members know these as ADW's AI developer workflows. AI coding is not enough. We need more than just generating code. We need engineering workflows. We're interacting with Git, we're interacting with the file system, we're writing code, we're updating files, right? There's a lot more going on in day-to-day engineering tasks. We've created 3 new work trees, and they're all operating on their own branch. So this is the setup process, all right? We already have our plan, and now we're setting up our code bases. So we're not quite building yet, but we do have our branches and our trees set up for our agents to operate in. So this is a powerful parallel agentic coding workflow you can use to scale your impact. I'm going to show you in just a second how powerful this can be, all right? Because we're going to get multiple versions, we're going to get multiple future realities of this code base that we can pick the best pieces from, and you can choose exactly what you want to go back into the main timeline, AKA your main branch, all right? So right now we're about right here. Let's go ahead and continue our journey. We have all of our code bases set up. Let's go ahead and give our agents access to what they need to ship this feature. Let's go ahead and open up .claude back into the commands directory. This is one of 3 essential directories for agentic coding. But let's open up the exe.parallel. So this is where we're actually going to fire off every one of our agents. You can see here, we have that same workflow, right? We have variables at the top. Our variables here are the plan that we want to execute and the number of parallel work trees. So the number of agents that we want to fire off. You can see the rest of this prompt is pretty straightforward. We're basically saying, give every agent their own dedicated code base and pass off this plan to them, okay? So let's just kick this off, right? I'm gonna run /exe parallel. The plan we want to execute is, let's go ahead and pass in our UI revamp. Okay, so we're gonna update the Thought Bench application, all right? Copy the reference to this, and I'm gonna pass this in here as the first argument. When you're working with Claude Code /commands, it's based on the index. So the first argument here is going to be, our first parameter. And then the second one is going to be whatever we pass in next. For the number of parallel work trees and our simple init parallel, we set up 3. So I'm just going to pass in the number 3 there. This is going to be really powerful. Claude 4 Opus is now going to spin up 3 instances, right? It's going to set up 3 subtasks, 3 parallel subtasks, and it's going to start building out this feature that we've, fully planned here. Viewers of the channel and principal AI coding members, that great planning is great prompting. I'm going to repeat this over and over and over because it becomes more and more relevant as you get access to more compute. The best way to communicate is to write clearly, is to think clearly, it's to plan. And then we hand off these great packages to our AI coding tool. This is what we're going to do now, but instead of doing it with just an AI coding tool or even an agentic coding tool, we're passing it off to the state-of-the-art Claude 4 Opus in multiple instances. Okay, this is big. Okay, we talk about scaling, we talk about long-running agentic workflows and long-running agentic coding jobs. This is how we scale even further beyond. Let's kick this off without further ado. Bam, then it's going to get to work for us in the background. Okay, so we had a couple of commands to run. I wanted to understand the code base. Well, first I wanted to go back to the root. I then wanted to understand the high-level structure of the code base by looking at the server and client directory. It's then going to run tree to understand, a deeper look at the code base. And then it's going to read the plan we passed in, right? So UI revamp. So there we go. So now it's going to read the UI revamp plan. Fantastic. So this is where, a lot of your engineering work is going to happen now moving forward, is in the planning, it's in the thinking, it's in the engineering of the work you want done. And then we're going to create 3 parallel agents to implement the spec in their own respective code bases. Okay. So this is going to be really important. You're going to see 3 tasks kick off here. And I'm really excited for this. This feature is absolutely insane. So we got some tokens leaking in here, some Opus tokens, right? So this is very expensive. By the way, kicking off this many agents, doing this much work is expensive. This is advanced agentic coding. So there it is. These are all running in parallel. Okay. It looks like this top one is the only one running. These are actually all running at the same time. We're going to let this run. This is actually going to take quite a bit of time. This is a non-trivial set of work. So we're going to let our agents run here. We have auto accept on. Inside of our settings, we have enabled several, let's go ahead, I can show that to you. Inside of our settings, we have several commands, just default on, enabled to let Claude Code cook. So that's that. While this is running, let's talk about why you would want to do this. Okay, why do you want parallel workflows? What are the concrete advantages of this, right? What's the true edge that we're getting, right? Every week, every Monday, I try to come to the table, quite literally to the table here, and I want to give you valuable engineering insights you can use, right, hands-on in your engineering work, okay? So how is this useful for you hands-on? Let's talk about it. You can see we're still working there. Let's go ahead and open up the README and let's break down a couple of key ideas here. Okay, so why run in parallel? LLMs are non-deterministic probabilistic machines. Okay, that means that every time you run, you're going to get a different result, right? The same prompt will give you different results, especially when we're talking about the scale that we're trying to operate at, okay? I don't care about one-off quick changes. I don't care about greenfield applications. I don't care about small tweaks here and there. I'm talking big, long-running jobs running tons of engineering work. That's what we're aiming on the channel. We want a ton of work done by agentic coding tools and beyond. With those long-running jobs, we can be guaranteed that if we run it twice, we're going to get different results, okay? Now, you might think that's a bug. It's not. This is a feature, right? Just like you and I, we are non-deterministic token generating machines, okay? The thing I'm going to say next, duck, banana, infinity stones, right? You won't always know what I'm going to say next, okay? You can guess, right? You can have high probability, right? Especially if you're operating in the domain space that I am and that we are, but you cannot know for sure the next token I'm going to generate here, right? That's part of why you show up every single week, okay? It's because the tokens I'm generating, right? They're differentiated tokens, right? In this video, it's another example of that. Make sure you're subscribed, blah, 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 okay? So, so this is a feature, okay? Not a bug. That's my point here. We can leverage this to see multiple versions of the future, okay? We now have the capabilities to build out multiple futures of our code base, and then you can choose the best outcome. This is why this is so powerful, okay? By running multiple agents in parallel, we can do this. We can hedge against model failures on complex tasks. It's very possible one of these tasks is just going to fail, all right? It's not going to update the UI. It's going to run into some bug. You can see 17 tool calls there. It's just going to fail, okay? So that's very possible. And the advantage here with multiple agentic workflows running, right? We have multiple agents working for us. The advantage here is that 2 of these might work or 1 of these might work, right? And you can spin up way more than just 3 agents here, okay? I'm just showing this off. This is a simple minimalistic example that I want to share with you here. So this is one reason to run multiple agents in parallel, right? This already beats out you doing this by yourself, running a single instance, okay? Let's look at number 2. We can get different perspectives on the same problem. And then, once again, we can choose the best. So why is this important? So for something like user interfaces, which is a great example of this, we might have a general direction of what we want, but we might not know the exact version we want, right? In our case, we are revamping the UI. There are many acceptable versions of this, right? And as you'll see in this video, there are multiple end states here that we're going to end up looking at. All right, so third, we can isolate and delegate our engineering work to 2 to N agents. There really is no limit on this, okay? I just chose 3. It's a great number. It's a great place to start. You want 3 different versions. And, this is going to give you a great starting set of futures of your code base to choose from, right? We're going to be able to merge the best of 3, right? So we're getting, again, 3x chances. We're using 3x compute to improve the final result that we have. So this is why we run in parallel. So let's go ahead and take a look at our code here. It looks like Agent 2, check this out. Agent 2 is complete, used only 10 tools, very interesting. Let's go ahead and it looks like it wants to tail. It looks like it's fixing something. Let's go ahead and just accept. So you can see very cool, right? So Opus ran 10 tools, 67,000 tokens, ran for 5 minutes inside of task 2. Okay, so task 3 and task 1 are still running. You can see here we have a ton of tool uses in Codebase 1. We're definitely going to get some very different results, right? We can already see that just based off the number of tool calls, okay? So this is going to need some more time to run. You can see task 1 still stacking up the tool calls. You can see we just got our results.md right, and that should be the end of the parallel tool. If we search for results.md, you can see that was one of the last commands there. All right, so you can see here we got task 1 also completed now. So task 1 took 9 minutes, okay? Basically 10 minutes, all right? So look at these long-running agentic workflows, right? 80K of Opus tokens. There's going to be a lot of value in there. And our third agent is still running. So it's got 24 tools in use. So this is going to be a pretty great result. Let's go ahead and let it finish up. And let's just briefly talk about when to use this powerful technique, because you don't always want to whip this out, right? Again, as you can see, it's going to take some time. But the nice part is we're building out multiple of these in parallel. So it's almost like it'll always just take the duration of your longest agent. There's definitely an argument for just constantly using multi-agent Git Worktrees. But let's go ahead and just take a look at this. Okay, so when to use this technique. It's fairly simple, okay? It's perfect for, in-state ambiguous tasks. When you have UI work where many versions can be acceptable, okay? When you think one of your hits, one of your agents might fail, when you think you're working on a hard task, fire off 3, fire off 5 agents, and then see which one, maybe pulled it off. And then, of course, this is probably the most important one. I probably should have put this one first. You need to have a clear plan, okay? And you need to have enough work worth putting in its own branch, okay? There is a huge argument for always using plans, right? Pretty much all my work comes out of a spec now. I'm thinking, I'm writing, I'm planning, I'm AI drafting with my agentic coding tools. They're helping me plan now. If you can't write a plan, right? If you need to iteratively prompt, you probably shouldn't use parallel workspaces, right? It just isn't going to make sense. You probably should just iterate on your own code base. If you have any one of these, and specifically if you have 3, right? If you can plan your work, if you can see ahead, if you do know what you're looking for, parallelism is going to be really, really powerful. So here we are, agent 3. We're up to 33 tool uses. So while this is working, we're going to need a front-end script to boot up all of our front-end servers. So inside of the initialization parallel script here, I only updated the client port. This is because we're only making a front-end change. So we can actually run the main server here, so we should be able to just use our existing code bases. Okay, check this out. This is awesome. We have all 3 agents finished. So let's go ahead and look at that total runtime. Okay, so check this out, right? We have 3 agents that ran 9 minutes, 5 minutes, 14 minutes. There is our summary. So we got our results summary. In order to spin these up, I would love to just look at these side by side. Create, start tree clients. .sh, say for each work tree, start the client. And let's go ahead and kick that off. Okay, there we go. Let's go ahead and check this out. Start clients. We can go ahead and just look at this. Yep, this is perfect. UI rewrite. And then you can see we're running. It's got some nice logging here for us. And then we're going to wait for all the processes. Looks great. Let's go ahead and kick that off. Okay, there we go. It's giving us the permission to unlock that file. Great. So go ahead and kick off this file. And to note, if we type GS here, get status, we only have this one change in our primary branch, right? All the other changes have been isolated into our trees. But okay, without further ado, let's go ahead and copy this, SH. Kick that off. We're going to start all of our clients at the same time. So let's go ahead and boot these up. Client 1, client 2, client 3. These are all connected to the main server. So let's go ahead and kick this off. You can see a little bit of difference already. Let's go into the Thought Bench application because that's where our change was focused. So there's 1, there's 2, there's 3. And check this out, guys. So here's the original, right? So we can type hi here. There's the prompt, right? It's going to kick off, blah, blah, blah. All looks good. And then here are our other versions, okay? So here's the Version 1, you can see we have a terminal-like style. Here's version 2. Look at this. Really like this one. Really clean, right? Kind of modern. I love this like highlighting blue modern style here. And yeah, we can kick off a prompt here. Let's see this work. Yeah, nice. Look at that. So interesting, kind of an overlay setup, right? Very kind of futuristic look. A little bit harder to read here. And obviously, you know, there's some styling problems here, but you know, that's not the focus. Obviously, we can come in with follow-up prompts, clean things up. I really want you to focus here on the fact that we have multiple working versions of the application that we can play with. Here's version 3. Very interesting, right? So we can say, how are you? Just some whatever filler prompt, and check this out, right? So I like this version too. It's a bit more just straightforward. Let's go ahead and reset here and type hello. This version is like really compressing the overlays to save space. You can see all the font is a lot smaller. This is really cool, right? We have multiple working versions of this new application, okay? I gotta say I like the second version the best, right? Thought Bench. It kind of fits our previous kind of, you know, theme. It just kind of takes it to the next level. Obviously, we have some styling fixes here to improve, but I love the buttons. I love the styling. I love the feel of this. And we do save a little bit more space here by having them a little bit more compressed, right? We can go ahead and reset, type hi. And yeah, I like the way that these loaders are set up as well. Anyway, this is awesome, right? We have multiple versions of our workspace, right? We created 3 versions of our application. We updated the client in every version with Claude Code running Claude 4 Opus. We wrote a plan. This is really important, right? We have to know where our role is, okay? So we wrote a plan. We parallelized our agents to run in their own isolated environments, executing against the exact same plan. And then here we are. Let's go ahead and merge the best take. So I like, right, this second version, just as if I was an engineer operating in this code base. I'm gonna open up Cursor and I'm gonna go into trees. This is UI rewrite. I think this is 2, all right? So, you know, we are now inside of a version of the application. And let's see, how can I identify this? We should be able to search this port. Let's go ahead and search this port. Perfect, right? So we can see that that port is right here. So this is indeed the second version. Okay, we can run git status here to see all of our changes. And then we can run, you can see we're on that second branch. Here's the results file. This is a great pattern for having your independent agents summarize all of their work. Everything's working as intended. And now we can also just check git diff -- stat. So we can see, I think we need stat head. Is that right? Yeah, there we go. So, you know, compared to the main branch, you know, we had 630 lines changed here agentically. We didn't touch anything. We didn't do anything. All we did was plan, right? Once again, great planning is great prompting. Every principal AI coding member knows that. I highly recommend if you're not planning your work, I think you're probably starting to fall behind the next wave of what can be done with agentic coding tools like this. Okay, so let me go ahead and what I'm going to do here is I'm going to fully commit. So I'm going to say GCM, I'll say UI rewrite agent 2. And I'm just making some crap up here. Just as if I was an engineer operating on this branch, I'm just gonna git push this. Okay, so we have rewrite 2 pushed. Now I'm gonna come back to the main branch, okay? You can see there's the Worktrees. If we run git branch here, this is, you know, git branch. I have short codes for all this to move faster. You can see all the primary branches there. Now we're going to merge in branch 2, right? So we can see we have our start client. We can go ahead and commit that. And let's go ahead and merge that branch in. So I'm gonna copy this. And just as you would with another engineer, we run git merge this branch. Bam, there are all those changes. Now we should be able to see our original branch, right? Here's the original version. If we refresh, whoops, if we open up that Vite file, we can see we did get that merge in. So I'm gonna reset this back to the original port. I'm gonna kick off our script here, open this up. And if we go into Thought Bench now, we of course have that new updated version, okay? So like I mentioned, you know, there's still some fixes here, right? We need to make sure that this text is readable. We can now, back in our main branch, if we wanted to, you know, deploy a quick change to make sure that that text is readable. You know, we can always just open up Claude instances and fix these changes. I'm not going to focus on that right now. I just wanted to highlight this interesting idea of having multiple agents working for you in parallel in the background. Now we have multiple versions of this application that we can pick and choose from. And the sky is really the limit here. You can set up as many agents as you want to. If you check out the Benchy codebase, link in the description, I have a init parallel as well, which takes a more dynamic approach where we can create however many parallel work trees we want in a single shot. All right. And this enables, once again, instead of just running 3 agents, we can run 3 to n agents. And the whole purpose here is that we have multiple shots at the future that we're looking for, right? We have multiple perspectives, we have multiple versions, some successful, and we get to pick, right? We get to merge the best. This is Git Worktrees, parallel agentic coding, plan your work, run multiple agents in parallel with Git Worktrees, pick the best, merge the best, and then keep shipping. This enables you to pick multiple best versions. You're not just writing fast. You're not just, generating a lot of value for your company, for your work. You're generating the best of n possibilities for your work, for your company, for your engineering, okay? Merge the best. This is just one of many ways we're exploring how to maximize our engineering impact with compute. Make sure you're subscribed. And if you haven't already, make sure you check out Principled AI Coding. This is a foundational course I built to help you excel with the AI coding tools of today and tomorrow. In this course, we use the old school AI coding tool Aider. In the next course that I'm working on as we speak, week after week, we're going to be talking a lot more about agentic coding, but it's really important for you to set up your foundations, okay? In this course, we set up the foundations, the principles of AI coding, and this is the only way I'm able to, literally 6 months after this course has been released, I'm able to still reference this course and the ideas in it, okay? Context, model, prompt, go from beginner to intermediate to advanced, it's all there. Make sure you get the value embedded inside this course, close the loop, let the code write itself. ADWs, as you saw here, AI developer workflows, also known as agentic workflows. This is a reality. This is no longer something that's hard to do. This is something that you can do right now. If you want that extra oomph, if you want to prepare for what's next, check out Principled AI Coding. Like I mentioned, I am actively working on part 2, phase 2 of this course, where we're going to push everything we've done in Principled AI Coding into the next level with agentic coding. Claude 4 is here. Claude Code is out of research preview. This is all big news. Claude 4 Opus is insane. Claude 4 Sonnet is a great workhorse. We have more tools to leverage compute. Take these ideas, write with multiple agents at the same time, get more work done, choose the best of n. You have more compute than ever available to you. I highly, highly recommend you invest in this tooling. There's a reason I've talked about Claude Code literally month after month now, literally like 8 videos in a row. It's because I can sense the signal. And as we've seen here with the code with Claude, announcement and everything that was released here, I hope you can start to see the signal too. Claude Code is a differentiated agentic coding tool. Check out previous videos to understand more. There's lots more to discuss here. There's lots more edge I have to give you, so make sure you don't miss it. We're pushing into the agentic coding future. We're now running multiple agents in parallel to scale our compute, to scale our success. You know where to find me every single Monday. Stay focused and keep building.